All right, this is section 8.6. We're going to be talking about DeMoivre's theorem. Okay, so what's the goal of this section? The goal of this section is to be able to take the roots of complex numbers. So for example, I would like to take the fourth root of -8 plus 8 square root of 3i. How do you take a root of a complex number? That's what we want to be able to do in this section. Okay, so some preliminaries for this section are, well, if you should have watched the previous video in 8.5. We want to be able to express complex numbers in polar form. So you're going to want to be able to write a complex number in rectangular form. You want to be able to rewrite it in polar form. Remember that there's this value r called the modulus, and it's kind of like a radius. You find it by doing the square root of the real part. So the square root of the real part squared plus the imaginary part squared. You're also going to have to find an angle theta, which you can find by doing tangent inverse of the imaginary over the real part. Another thing you're going to want to get out of, or you're going to want to be able to do, is multiply complex numbers in polar form. We covered this in the previous video. How do you multiply two complex numbers in polar form? And here I have the little rule. If you have this complex number r1 cosine theta 1 plus I sine theta 1 times r2 cosine theta 2 plus I sine theta 2, the product is just the product of the moduli times cosine of the sum of the arguments, the sum of the angles. Another thing that you're going to need for this section is, well, just some basic trig, just some trig identities and just basic trigonometry. All right, let's get into it. Let's, before we find square roots, let's first just raise complex numbers to a power. So right now what I want to do is square complex numbers. I want to raise them to the second power. Well, imagine I was given a complex number in polar form, r cosine theta plus I sine theta. I want to square that. Well, to square it, it just means that it multiplies by itself. And we know how to multiply complex numbers in polar form. It's just the product of the radius or the moduli, so r times r, so r squared, times cosine of the sum of the arguments, sum of the angles, so theta plus I sine theta plus theta, and well, theta plus theta is just 2 theta. So if I want to square this complex number, r cosine theta plus I sine theta, it ends up just becoming the modulus squared times cosine of double angle plus I sine of the double angle. If I wanted to raise the complex number to the third power, well, a similar thing happens. All you have to do is raise the modulus to the third power, and then you triple the angles. And if you were to raise the complex number to the fourth power, you would have r to the fourth, cosine of 4 theta, I sine of 4 theta, and so on and so forth. And this gives rise to DeMoivre's theorem, which pretty much just says that if you're given a complex number r cosine theta plus I sine theta, and if you want to raise that complex number to the nth power, then you're going to do just r to the n times cosine of n theta plus I sine n theta. And that's it. So let's just practice with this first. All right, so right now what you gotta do is raise this complex number right here. It was given to you in polar form, 2 cosine of 60 degrees plus I sine 60 degrees, raise it to the 8th power. Pause the video, take a few minutes, see if you can do it on your own. All right, so let's see. So according to DeMoivre's theorem, what I should end up with here, it should be 2 to the 8th times, and then it's going to become cosine of 8 times 60 degrees plus I sine of 8 times 60 degrees. Okay, well, what's 2 to the 8th? So 2 to the 6th is 64, 128 times 2 is 256. So 256, and then this becomes cosine of 480 degrees. Plus I sine of 480 degrees. And I mean, technically that's it. I'm going to take it one little step further, and I'm actually going to write it in rectangular form. So I'm actually going to figure out what is cosine of 480 degrees. So what's cosine of 480 degrees? We can use the unit circle for this. And well, also keep in mind that 480 degrees is coterminal to 120. So 480 is coterminal to 120. So if you look at 120 degrees, for 120 degrees, cosine of 120 is -1/2, and sine of 120 degrees is square root of 3/2. And if I actually distribute the 256, that becomes -128 plus 128 square root of 3i. Well, let me give myself a little bit of extra room here. -128 square root of 3i. That would be the rectangular form. So this is a rectangular form. Up here, in this part right here, we had the polar form. Alright, and that's all there is to that. Hopefully you agree. Okay, next problem. Similar idea. You gotta raise this complex number, 2 square root of 2 plus 2 square root of 2i to the 5th power. The difference between this exercise and the previous one is that in the previous exercise, the complex number was given to you in polar form to begin with. Here, the complex number is given to you in rectangular form. So you're first gonna wanna rewrite it in polar form and then raise it to the 5th using DeMoivre's theorem. Okay, pause the video, take a few minutes, see if you can come up with it yourself. All right, so let's answer this question. So first, let's say change to polar form. So let's change this to polar form. So I gotta figure out what is r, and well, r is going to be 2 square root of 2 squared plus 2 square root of 2 squared. That turns out is 8 plus 8. I hope that you agree on that because it's just 4 times 2. And well, that's the square root of 16, and so my radius is 4. Now theta is going to be tangent inverse of 2 square root of 2 over 2 square root of 2. Well, that's the same thing as saying tangent inverse of 1. And well, remember right now that theta, what's the range of tangent inverse? The range is from -pi/2 to pi/2. So something in quadrant 1 or something in quadrant 4. So can you think of an angle in quadrant 1 or in quadrant 4 for which tangent is 1. And well, what I'm going to say is that that angle happens to be 45 degrees. Let's agree to work with the degrees, yeah? So let's agree to work on degrees. So degrees, I'm going to say here. Okay. So I have, I think, what I want now. I have been able to express, first of all, my complex number in polar form. And the polar form of my complex number is 4 cosine of 45 degrees plus I sine of 45 degrees. Yeah? Okay. And now what I gotta do is I gotta raise that to the 5th power. So according to DeMoivre, this is going to become 4 to the 5th times cosine of 5 times 45 plus I sine of 5 times 45. Okay. Well, that becomes what? What's 4 to the 5th? 4 to the 5th power is 1024. Oops, 24. And then this becomes cosine of 45, and 45 is 90, 180, 225. 225. Okay, and that's it. I mean, we could leave it at this. This would be the polar form. Or if we wanted to write it in rectangular form, we would actually have to find what is cosine of 225. And well, cosine of 225 is going to be, well, let's just go all the way to the rectangular form. So that's going to be negative square root of 2 over 2 minus I square root of 2 over 2. And then if I distribute the 1024, if I multiply 1024 times negative root 2 over 2 and 1024 times negative root 2 over 2, it's going to become negative 512 square root of 2 minus 512 square root of 2 I. That would be the rectangular. That's the rectangular form of this power, of this complex number raised to the 5th. Okay, so hopefully you agree with the operations that we did here, with the little process that we went through. Let's do the same thing for this exercise. So pause the video. Pause the video and give yourself the opportunity to try this one. So raise this complex number to the 4th power. Okay. Just for the sake of time, what I'm going to do is I'm just going to tell you what I got. So if I raise this to the 4th power, I'm going to have the following. Here I'm going to skip some steps. I mean, the first thing you're going to want to do is rewrite the complex number in polar form. I'll let you do that on your own. I'm just going to kind of get to that point already. So this is going to become 2 cosine of 330 degrees. Cosine of 330 degrees plus I sine of 330 degrees. So it's going to be up to you to figure out how I got this 2 and how I got the 330 degrees. So remember that you're going to have to then, in order to figure that out, you're going to have to convert this complex number in rectangular form to its polar form. And I gotta raise that to the fourth. Okay, so if I raise this to the fourth, this is going to become 2 to the fourth times cosine of 4 times 330 plus I sine of 4 times 330. Okay. And 4 times 330 becomes 1320. So this becomes 16 times cosine of 1320 degrees plus I sine of 1320 degrees. Yeah. Now what's cosine of 1320? Turns out is negative 1/2. And the sine of 1320 is negative √3/2I. So if you were to distribute the 16, this would become negative 4 minus, negative 8. Negative 8 minus 8√3I. Okay, so I am going to stop this video, this first part, at this point. In the next part, that's where we'll be taking roots of complex numbers. So for this first part, we were raising a complex number to a power. In the next video, in the next part, we'll take the roots of complex numbers. Okay, thank you, and I'll see you in the next video.